Hi guys, welcome back. It's me again. We're doing 5G, so this is just pretty much worded questions based on our linear equation stuff. So it's reading the question really carefully, interpreting what it's asking you, and looking at graphs to work out to answer questions. So, have a look at the work. Maybe you can copy that down now, leave the little gaps. Make sure you pause the video if you need to write. Alrighty, so it's a little bit of a rush graph. This is an example from the textbook, but I'm going to explain exactly what to do. So, water is pumped into a partially full tank. So if you look at our graph over here, it's always good to look at it and see what the axes represent. This is the volume in litres, and I haven't put all the values in. And this is the time in minutes. So it's all there. So it says here, water is pumped into a partially full tank. So it doesn't start at 0, it starts at 200, we can see there. The graph gives the volume after t minutes. It says how much water is in the tank initially. Initially means when time is equal to 0. So when time is equal to 0, 0 is here, we can see that our y-intercept is 200. So we can say the volume equals 200 litres. Always use units, everyone, or else you will lose a mark. And that's it. So initially means at the start. How much water is in the tank after 10 minutes? And it says do this from the graph. Unfortunately, I didn't put in all my increments. So what we need to do is go across here and find where 10 is. So we look at 10. You can do this yourself from the textbook. We go up until we hit the graph like that, and we move it across. And because I rushed and did this quickly, I don't have the value there. So you read off the value, and it's as simple as that. So I can't fill that one in. How long does it take to fill to 2,000 litres? Okay, let's have a look. So 2,000 litres is when it's full. So it's right up to there. So that's when it's full. And we can look down here, go down, and it says 18 minutes. So our answer to that one is 18 minutes to fill it up. But remember, it didn't start from 0 litres, it started from 200 litres. So it filled up 1,800 litres, but it took 18 minutes. Excellent. Find the equation in terms of v and t. Alright, we always start with the y-axis first. So it's going to have v equals something. So v equals something. So remember, if we use, I'll just put the equation, the basic equation, y equals a plus bx. A is a y-intercept. Okay, but this time we're not using y, we're using v of course. So where's our y-intercept? We can look straight at our graph and see it's 200. So our y-intercept is 200. Because the gradient is in a positive direction. We need to work out what the gradient is. So, we've got our 2 points. You just need 2 points on the graph. I'm going to use this y-intercept, and I'm going to use my point that's right up at the end there. But remember, it doesn't start at 0, so we have to draw our triangle in from there. So be careful this time. So my run goes from 0 to 18, so I can see my run is 18, and my rise goes from 200 to 2,000. So my rise is 1,800. So to work out, we're going to have to simplify that. So the gradient B is rise over run. 1,800 over 200. We can simplify that. Chop off 2 zeros, we get 18 over 2, which simplifies nicely to 9. Whoops. The run is 18. What am I doing? Sorry. Rise over run. The run's 18. That was silly of me. Thank you. So 18. See, even I make a mistake sometimes. I'll start again with that. The rise is 1,800. I had it written there. Thanks for that, Mr. Kendrick. The run is 18. So, they can cancel and we get 100. Do it on your calculator. 1,800 divided by 18 is 100. Thanks. Okay, so the gradient is 100, which is great, and then we put an x there. So there's our formula. It's not x. Nearly made another mistake. That was silly, wasn't it? We use t. Normally we use x, but in this case, the x-axis is t. So we put in a t there. Find the volume using our formula after 15 minutes. That means the time is 15 minutes. So So what we need to do is substitute T equals 15 into this formula. So we've made the formula, now it's a matter of just substituting it in. Volume is 200 plus 100 times 15. 200 plus 10 lots of 15 is 1500. Volume is 1700. And write the word litres. Always make sure it's a sensible answer. Remember, use common sense. After 15 minutes, is it 1700 litres? Let's look over here. After 15 minutes, so it's about there, is it? Yep, it's nearly full. So it's a sensible answer. It's somewhere up here. So it's almost up to 2000 litres. And it says here, what rate is the water being pumped into the tank? So we can use our formula for that. This is our y-intercept, 200, and this is our gradient, which means every time time increases by 1, it goes up by 100. So that is our rate. That's our rate of increase of water. So the rate is being pumped at 100, and now what would the units be? It's litres for every second. So it's litres per second. So it's 100 litres per second.
Per minute.
Per minute, sorry, the units were minutes. I knew that, I was just testing Mr. Kendrick, per minute. So you just look at the units on your graph. Alrighty, and then so some of the graphs will be, instead of being increasing, some of them might have a full water tank and it might be decreasing, which means the gradient will be negative. So just be careful of that. Now you guys can do exercise 5G, have a go of that, and I'll see you soon.